Well, one of the first things I hope you all can address is probably one of the criticisms, or maybe criticism isn't the right word, one of the challenges that we all face when we're talking about thinking outside the box. Do you have problems not being taken seriously when you propose your ideas? And if so, how do you deal with that? Anybody can go first.
Okay, well, yeah, I've encountered that quite a bit. And, oh gosh, there's a few layers to this. One, a negative reaction to a new idea is absolutely normal, and if you know that it's normal and are prepared for that, it helps take out the sting. And that is a temporary reaction that can be overcome as there's more substance behind it. Another way to do it is couch, depending upon how the idea is, just a science fiction notion, what if, to put it in terms where it sounds, where you're presenting the idea with the same sort of, I'm trying to figure out how to put it this. If you're dealing with a very speculative idea, rather than trying to make it sound like a more refined idea, just say it's speculative or science fiction-y and a what if to provoke discussion. Another thing that comes out very useful is who you choose to talk to. If you try and go to a average expert, you're probably not going to get that good of a reception because, well, that's too long of a story. If you go to the higher quality people, especially if you're challenging some old ideas in physics and stuff like that, the ones who actually remember some of the original assumptions that went into some of the theories and where the gray areas are, where are the cracks in the armors of that, and much more constructive discussions. The other part about when doing this is be impartial. In other words, don't go and say, I have this great idea and it's wonderful. It's like, I've been thinking about this. I don't know if it's right or wrong. You want to talk it out a little bit with me? That's a completely different way of doing that. So that's some of the techniques I've used.
This is live, I think. I think one problem of our times is basically the information explosion. The supersaturation of our culture, particularly the culture of young people, with endless visions that are constantly broadcast to the extent that it stimulates a very short attention span. Oh hum, it's just another vision of the future and they're all equally believable. And secondly, that because of that short attention span, nothing is taken very seriously. And so you lose the careful evaluation of things, the distinction between what is fiction and what is something that's potentially realizable very quickly, for example, in a decade. And I think that because of that, the whole challenge of the frontier is threatened. We had a bit of a discussion last night about that with some people, and the feeling that in the old days, if you lived on the Atlantic coast in the first cities built here, that when it became possible to get over the mountains and become a landowner and develop it, the challenge was there, and brave people would go out into the wilderness and do it. And the large majority of people who stayed back at home had a very comfortable psychological position that, well, it's there. If I ever need to or want to, I can do that, and therefore I support the idea. And I think that this is something that has mostly evaporated among the average people out there, and of course the average taxpayers. And so it makes it very difficult for innovative things to have the high impact that they might to stimulate the kind of open-ended development of space that we're looking for. And that's an observation. I don't quite know what to do about it, but I think it is a description of the cultural situation now among young people in particular. And if some of the young people in the room would like to comment on that, I'd like to hear what they have to say.
Well, is this on? Hello? Okay, so yes, I think young people are the key, and I'm really excited and glad to see the young people at this conference. I guess a lot of it depends on what you're looking for, and you know, and we all have different kinds of ideas we're putting forth, and different ways in which many times those ideas are being kind of like pushed back. And one way in which I experience that is that I'm putting forth a realist interpretation of quantum theory, and in many academic circles that is viewed skeptically because of the long press of history and the tradition of kind of saying, you know, oh, you know, the enlightened position is to not talk about what reality is really doing, you know, and you're kind of dumb if you're doing that. And but fortunately, there's a pressure now among new generations of young physics students and other physics, and not necessarily physics, but students in general, who realize that, you know, I guess I'm tendentious language here, but who think that, like I do, that if a theory works well as quantum theory does, it's not just magic or a coincidence that it works well. Reality is doing something that causes that theory to be a good model, and that's what's intriguing. And so if the young people can come up and stay strong and don't let the teachers drum that curiosity out of you, that's where we will make progress. Don't be satisfied with people saying, you know, the enlightened position is to stop asking questions and stop asking why this theory works. No, that is not the enlightened position. So just, it's the young people are our hope, I think.
I agree 100% with what you just said. It is endemic in physics departments that if you go into a physics department as a young student and say, well, I'm here because I want to find out what the world is like, you'll learn very quickly that physics is about predicting the position of gauges or measurements that you get off a computer screen or a dial. And if you say, well, what department should I go into if I want to find out what reality is or what space-time is, you will learn very quickly not to ask that, because this will be seen as an aberration, and that it will have adverse consequences for your career and your academic life.
But do it anyway.
Yeah, I'm very much a realist. The only caveat that I would add to that from my perspective is it's very important for us. I'm generally a realist and a pragmatist, and from the pragmatic pushback on that, I think it's very important that we not take these models too seriously, and always keep in the back of our mind that there tends to be a behind-the-scenes sort of explanation for why we observe the things we do. There's an explanation for what we observe, and our observation of it, our perspective, tends to be decisive in a lot of those situations.
I think also there are good teachers out there. You know, you don't want to close off asking questions, because sometimes, I know my mentor when I was an undergraduate was amazing. You know, with his encouragement, I went on, switched my major from the College of Fine Arts to getting a degree in theoretical chemical physics, and then a doctorate from Harvard in atomic and molecular physics. So they're out there, and I think the teachers who brought you here today are samples of those teachers who are more open-minded. You just have to find the people to work with.
The other thing that comes to mind is in how others react to our ideas is how you act to when you're hearing a potentially crazy sounding idea. And the technique that I've ended up using is, instead of trying to judge whether or not the idea is right, I look at how the person is going about investigating it. If it's, this is my idea and I'm wonderful and it's a sales pitch thing, not so much. If it's like, I don't know if this will work or not, I want to explore it and it has value, then I listen. So I pay more attention to how the people are going about their investigation and about their idea, rather than about trying to prejudge if the idea is correct.
Good, good. Okay, Buck, we do have a question from the audience for you. The question is, you mentioned the importance of watching that certain mathematical errors or inconsistencies do not promulgate into future math development for science advancement. What did you mean by that?
Okay. One of the things that occurs often in information systems development, which is the overwhelming majority of software development today, one of the things that you want to do is separate the users of the system from the developers, because what will happen is the developers will tell the users this great database function that can be used to get the information that that user needs. And you have to put a wall between these two, because users just, they are doing something very different than the software developers. In this case, what we've got, and let me explain that difference a little bit. If you're using a website that is really well designed, you don't see it. It's like when you're reading a book. When you're reading one of her novels, you're off in space and you're having this cybernetic experience with the character. You're not looking at letters and words on a page. And that's good writing. It's also good user interface design. A really good user interface is invisible to you. You just bought the book that you wanted. And you're happy about that, and you don't remember what you clicked on and where you had to go to get there. Clearly, the Amazon interface was not designed by database people. It was designed by somebody who said, I'm not going to let these two talk to each other. I'm going to talk to somebody who wants to wants to buy a book, and I'm going to figure out the least number of clicks to get them to do that, so it is as invisible as possible. Okay, switch over to what I'm going to call a new Copernican model development. The intractability of the problems that I mentioned before, where since 100 years ago with Einstein's 1905 miracle year, since that time we've had the best educated brains, the most expensive equipment, everything you can imagine we have thrown at these inconsistencies for a century, and we have not solved it. That means, and this would never be tolerated in the corporate world, this kind of successive failure. It's a dead easy indicator that an assumption is wrong. It looks absolutely common sense. We believe it's true. We're so sure of it that we can't even recognize it. It's like the sun if you were a pre-Copernican, if you were in the early days before Copernicus, and someone came to you and said, yeah, the sun comes up and goes down over there, but it's not really moving, that person would sound crazy to you. We're moving at 1,000 miles an hour. That sounds crazy. We're in a similar situation where there's something very obvious to us, and there's some very strange ideas. I don't know if anybody knows. I've just recently heard about the holographic universe model. We don't know what space-time is, for example. We know it's something we observe, and if it's just an observation, but we can't know.
See, it's sort of like, it seems, I agree with so much of what Buck is saying. It's obvious to us that we live in space-time, that space-time is real, that it's this big real container that everything real lives in. And that is so obvious to us, but it's what's not true. And that is the Copernican revolution that I think we need to make with quantum theory. In other words, that space-time is a construct that has to do with I don't want to get it has to do with the way quantum interactions lead to the emergence of events that are connected. And you can talk about events, but events are things like absorptions, emissions. They're physical things that result in experiences. And I'm not going to say that all there is experiences. No, I don't believe that at all. I believe there are real physical things going on. Mm-hmm. But space-time is, again, it's the slide I showed, it's the tip of the iceberg. There's a whole lot going on that leads to the emergence of the space-time construct. And we never, do I see an x-axis anywhere? Do I see a time? I never see, when you draw a space-time diagram, it's a map, it's a construct, very, very useful. You can use it to create your theory of special relativity. That's a great theory that works really well, that coordinates all of these events and absorptions and emissions, and it's great. But we never see x-axes, we never see space-time intervals. We don't literally see them. We infer that, you know, that's a representation of physical processes that are going on. So.
Oh, I wanted to add something too as a observation. How many have heard of dark matter and dark energy?
I think.
How many have heard of the phenomenon on which those are hypotheses? Okay, so that's the problem, is that we talk more in terms of dark matter and dark energy, but that's just the working hypotheses. In other words, that's like jumping to a conclusion. I would much feel more direct if we were describing what are the physical observations for which those are the hypotheses, rather than naming them by the hypotheses.
And then it takes on a life of its own and becomes real, even if it might not be.
Yeah, there's a little bit of danger in that point of view, though, because things that you observe and are interpreted by plausible assumptions become what everyone believes to be true. However, it could be a misinterpretation, and dark matter is a perfect example. It is very true that the dynamics of the way galaxies rotate, the velocities of the stars in a galaxy are easy to measure with routine astronomy. And so people say, well, the only way that we can explain that they're not making Keplerian motion like the planets around the sun, it looks more like it's a solid object rotating, and therefore there must be an enormous amount of stuff that we don't see that is rotating with it, so it's more like a solid thing. And so they've expended millions and millions of dollars and thousands of hours of brain time looking for those invisible particles, sometimes called WIMPs, which are weakly interacting massive particles. And this might be wrong. In fact, an unknown author that I know pretty well is writing a book right now suggesting that it might be dark angular momentum and instead of dark matter. And the point there is that angular momentum is everywhere, right down to into the quantum world. It's known as spin there. And what if the universe at large is some sort of quantum entity that also manifests the spin phenomenon? Then as you concentrate matter and make a galaxy, does it amplify the effect so it becomes observable? And every morning, the first thing I do is go to the refrigerator and get out a plastic jug with a lid on it containing my orange juice, and I shake it like this to stir it up before pouring it into the glass. And every morning I think, isn't that wonderful? Here I am on the Earth that's moving 1,000 miles an hour, rotating and translating around the sun, and the whole solar system is moving around the galaxy, and this is perfectly inert to all of that. The phenomenon of inertia is right there. That's called the equivalence principle by Einstein, you can't distinguish between acceleration and inertial mass, and it's been proven to about 1 part in, I think, 10 to the 13th now, that this is true. And so there's an all-pervading thing right here in this room as we sit here and everything we do that we simply accept as a fact, but it's screaming at me anyway that there is something wonderful here that we don't understand, and we call it inertia, and that's part of the physics that we're dealing with now.
Yeah, I think it is. And I think Buck said that he has a digression and would like to finish. You had more to say, right? On the tape?
No, that's okay. One of the things that has been proposed that's a very strange idea in terms of conceptualizing space that is so strange, and it's very hard for me to and then I'm going to get back, I know who asked this question. I want to get back to answering that specifically. But one of the, I don't even know if there's a name for this, but it's been proposed that there isn't actually space, as I normally think of it. And it's more like a family, where a family is a set of relationships between individuals, and space is a set of relationships between, I don't know what the theory says, because my idea is space is sort of like a stage onto which things are put. But this idea is so strange, and it seems so counterintuitive, but I can't really find a hole in it, that I'm kind of attracted by it. I'd like to find out more what they're saying, and I think this has possibly links to what they call, to this holographic universe, another thing that seems equally strange and may be related or not. To get back to the point about testing, my recommendation on that was with the AI and the learning systems, where we're going to have them crank out these things that perhaps we are not intelligent enough, or for whatever reason our brain isn't structured sufficiently to develop the right sort of successful model. And perhaps we can have an AI learn a way to do this. And what I was focusing on there was, we need to ensure that they're testable in such a way that we can throw them out. If they are spitting out multiverse theories, or I heard one cosmological model that said, everything unfolds according to the will of Elvis. And to explain everything in reality, you may have to interpret lyrics very carefully, but if you look closely enough, you will be able to explain that everything unfolds according to the will of Elvis. That's not the sort of, we want testability from these things that the AI spit out, and avoiding assumptions that may build in and reproduce this error in assumptions that has tripped us up for 100 years. Hopefully, with luck, we can avoid it. I hope that, okay.
Good question.
Yeah, really. Does anybody in the audience have a question you'd like to ask any of our? This is a fascinating topic. We could probably go on well into the evening. I do encourage people to join us for the reception afterward, where you can grill them as much as you would like. We actually need to wrap it up now. I think from the point of view of the Theme 4 chair, I have been very excited by how willing people are to think about, what synergies can we bring about all these different ideas to imagine new physics that'll get us maybe to Mars first, then to Jupiter, then to the stars beyond. Who knows how far we can go. And I hope that if we come out of this with the inspiration and the dream to go as far as we can, whatever science fiction predicts, maybe someday we'll get out there and see if it's true or not. Thank you, everybody, for staying and coming to this, our symposium.